Hello, my name is Aiden Deming, and today I'm going to be presenting 8 problems today that a 7th grade math student may come across as they explore the lesson of equations and rational coefficients. Our first problem is x plus 6 equals negative 3. Alright, so the first thing that we need to do is to get all the variables on one side, because what I do on one side I have to do to the other. So we need to get all the variables on one side of the equal sign and all the coefficients on the other. To do this, we must first look at the 6 on the left side of the equation. When dealing with linear equations, I always tell myself, what I do on one side, I have to do to the other. So if I subtract 6 from one side, I have to subtract 6 from the other side. When I do that, the 6 cancel themselves out, leaving me with x on one side and negative 3 minus 6, which equals negative 9 on the other. So x equals negative 9. Let's move on to the next problem. Our next example is x minus 3 equals negative 5. Alright, so the first thing that we need to do is to look at balancing out the equation by having the x on one side and the coefficients on the other. So I'm going to look at the negative 3 on the left side of the equation. I'm going to add 3, so the numbers will cancel themselves out, and what I do to one side I have to do to the other. So I'm going to add 3 to the other side. I'm left with x equals negative 5 plus 3, which is negative 2. So x equals negative 2. Alright, so now we're going to try a couple of different problems using fractions. Yeah, you ready? Let's go. Alright, the first thing we're going to do is to make sure we have to balance out the equation with the variables on one side and the coefficients on the other. So we're going to look at negative 21 first. I'm going to add 21 to both sides because what I do to one side, I have to do to the other. So when I do that, I'm left with 3 over 4x on one side and negative 3 plus 21, which equals 18. To eliminate the fraction, I have to multiply by the reciprocal, which means I have to flip the fraction. So I'm going to multiply one side by 4 over 3 and the other side by 4 over 3. Because what I do to one side, I have to do to the other. So on the left side, I'm left with x, and on the right side, 18 times 4 in the numerator, which is 72, and 1 times 3 in the denominator, which is 3. So x equals 72 over 3, which when divided is 24. So x equals 24. Alright, let's try this example over here. A plus 1 over 7 equals 3 over 7. So what we're going to do first here is we're going to look at balancing out the equation. So I'm focused on the 1 over 7 on the left side of the equation. I'm going to subtract 1 over 7 from the left and from the right, because what I do to one side I have to do to the other. I have a equals 1 over 7 minus 3 over 7. And since denominators are the same, this makes solving the equation with fractions easy. 3 over 7 minus 1 over 7 equals 2 over 7, so a equals 2 over 7. Now, we're going to look at linear equations that ask us to use distributive property, which means we have to multiply numbers all the way through anything that is sitting inside the parentheses. To solve this equation, we have to multiply 2 all the way through. So 2 times 6x, 1 times 2 minus 7 equals 10. So after multiplying, I get 12x minus 14 equals 10. This equation can now be balanced, so I'll look at the negative 14 and add 14 to both sides, because what I do to one side, I have to do to the other. So the 14s cancel themselves out, and it leaves me with 12x on one side of the equation and 10 plus 14, which equals 24 on the right side of the equation. To get x by itself, we have to divide 12, which I'll do to both sides, which will leave me with x, and on the left, and 24 divided by 12, which equals 2 on the right, so x equals 2. We're going to try a problem using decimals now. Our equation is n plus 4.6 equals 0.7. First, we're going to look at balancing out the equation. I'm going to subtract 4.6 on both sides because what I do to one side, I have to do to the other. When I do that, I get n by itself, and on the left, and 0.7 minus 4.6 on the right. So, 9 equals 3.9. Our last problem is a real-world example, and since I love video games so much, we're going to solve a problem I've dealt with before. So here's the situation. Josh bought 2 video games that cost him $66.98. He had a gift card with a balance of $5 he wanted to use towards his video game purchase, and he's trying to figure out how much he paid for each game after the discount. Alright, so to set up this problem, we need to acknowledge that Josh brought 2 games, except we don't know the price of each one was. I'm going to use V as our variable for video games, and we're going to start with 2V because Josh bought 2 video games. Then, on the right side of the equation, I'm going to put the total amount for the video games, which was $66.98, and we're going to subtract $5 from that side in order to account for the discount from the gift card. So our equation will be 2V equals 66.98 equals minus 5.00. First, I'm going to do the simple subtraction on the right side of the equation. So 66.98 minus 5.00 equals 61.98. My equation now is 2V equals 61.98. Get V by itself, I'm going to divide both sides by 2 because what I do to one side, I have to do the other. V is by itself, and 61.98 divided by 2 equals 30.99. So V equals $30.99, which is what Josh paid for each video game after his discount.